Good evening, everybody. Okay, so we are going to have the first tutorial of this course. And let us start with any doubt if you have so far. Okay, so we have studied the spring system. And for these last 3 lectures, if you have any question, please let me know. Any doubt? Okay. If no doubt, so let's start with, we will solve some problems from the textbook only. So the first problem is problem number 2.1. Okay, so it says for the spring system shown in figure, and in figure you have this. So you have one spring here, then another one like this, and then you have like this one, and you have fixed here. Okay, and then what is given here is 3k, this is k, this is 2k, then this is k. Yeah, and you have these nodes shown, connection is shown basically, and like this. Then you have a force given here, which is equal to 50 Newton. Okay, so you have 3k, k, 2k, k, yeah, and then 50 Newton force here. And what you are supposed to do is, number one, number the elements and nodes. Yeah, so we will number elements or nodes. So you see both of them are connected, right? So this is, we call it node number 1, or just write 1. Then these, all of them are connected together, so we call this 2. Let's call this number 3, and let's call this number 4. So we have 4 nodes. Now element numbering, these are nodes, so we have 4 nodes, so we have numbered them. Then element numbering, let's call it element number 1, this is 2, this is 3, and this is 4. So there are 4 nodes, we have numbered them. Then assemble the global stiffness and force matrix. So finally we have to write this Ku equal to F format, and what it wants that what is K, this is B basically. Okay, what is K and what is F, that this is asking. Okay, and then it says number 3, partition the system and solve the nodal displacements. So that means the next thing is number C is U equal to what? Number D is find the reaction forces. So number D is reaction forces. Right? Okay, so this is the question. Now let's start with the force vector. So F equal to, and we accordingly can write F1, since we know that U1 equal to 0, right? So or you can write U also here. So U equal to, we have U1 equal to 0. Then so U1 equal to 0 means this is 0, because it's fixed. U4 is also 0 because the 4th node is fixed. Then you have U3, U2 we don't know, so we'll just write that U1 equal to 0, U2, then U3, then you have U4 equal to 0. Of course, transpose of that will be the U. If accordingly, if 0, if the displacement is prescribed, that means force is not known, so we don't know F1. Okay, now F2 is this one. This is a node 2. So what is F2? F2 is 50 Newton, right? So this force is being applied to this node. So we write 50 here. Then U3, the number 3 node is this one. There is no force here, so we'll write 0. And then you have U4, where the displacement is prescribed, means U4 equal to 0. So we don't know the reaction force. So we just write Y4 and transpose of that, because these are vectors. So we have a displacement vector and force vector. Now next thing is finding the K. Yeah, and for that let's draw it again here. So we have one spring like this, then we have this spring, then this spring, then we have this spring, right? Okay, so here we have node number 1, then we have node number 2, this is node number 1, this is node number 2, this is node number 3, this is node number 2, this is node number 4, right? So that's how we have done this, right? 1, 2, 3, and 4. Similarly, here we have 1, 2, 3, and 4. Then we have 3K, K, 2K, K. Yeah, 3K, K, 2K, K. So we write 3K, K, 2K, K. Right? So 3K, K, 2K, K. So we have the 3K, K, 2K, K. And now we have to, we can, you know that KE simply is equal to, or big K. KE is equal to simply this KE 1 minus 1 minus 1 1, right? So where we have the element number, and element number 1, 2, 3, and 4, right? So we have 1, 2, 3, and 4. This is how we decided the element number. Yeah. So here E means element number, right? Element number. Yeah, and this is the stiffness of, or a spring constant stiffness of Eth element, right? Where E is the element number. Yeah, so this is the K. So we know that for the individual one, for this one, for example, K1 is equal to KE, where KE will be KE means small k1 will be equal to 3K. So 3K here multiplied by 1 minus 1 minus 1 1. Yeah? And so on. So where we can write a state away, we can assemble here, you know. So you can write K is equal to, yeah, and we write like this, yeah, like this one. And we can have, there are 4 nodes, there will be 4 points. So 1, 2, 3, and 4. Here also 1, 2, 3, and 4. Sorry, and 4. Yeah. Okay, and now let's write that. Okay, so let's use different colors. So for blue, let's use for the number 1. Okay, so we can write K, because K is common in all of them. So I will just write K as a common. So write here. Okay, and then we just write the numbers then. Okay. Okay, now blue, let's write for the first one. Yeah, for this one. So we have 3, and the connection between 1 and 2 only. So between 1, 2, so we have to write here, 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 here. And what we have to write? We have to write 3 minus 3 minus 3, 3. So first one is done. Number 2, we have just 1, but this is between 1 and 3. So we have 1, 1, 1, 1, 3, 3, 1, 3, 3. And what will we write? Let's use different color for number 2. And we have plus 1, right? Minus 1, 1 and 3, right? Then minus 1, 1, right? So this is done. Okay. Now number 3, element number 3. Okay, this is connecting what? 3 and 2, right? So this means what? 3, 3, 3, 2, 2, 3, 2, 2. The first one is 3, 3, right? So different color let's use. So let's use yellow color. Okay, maybe we use red color. Yeah, okay. Okay, number 3. So we start with 3, 3. We start with 3, 3, right? This is the first one, 3, 3. So we start with 3, 3. So 3, 3 is here, and what is the value? Is 2. So plus 2, 3, 3. Then we have 3, 3. Then 2, 2. Right? 3, 3, 3, 2. And what will be the 3, 2? So 3 and 2. Right? So this will be minus 2. Then we have 2, 3. Right? So 2, 3. And what is the value here? Minus 2 again. Then you have 2, 2. Right? And what is the value? 2. So plus 2. Okay, done. Now we have one remaining, and that is this, which connects 2 and 4. This connecting 2 and 4. So 2, 4, this and this. So here, 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 and here. Let's use black color for that. So first we have 2, 2. 2, 2 will be again 1 only, right? This is a case, so only 1. So 2, 2 is only 1. So let me add here like this 1. Okay, 2, 2. Then 2, 4. 2, 4. So we have 2 here and 4 here. So right here, 2, 4 is minus 1. And similarly, 4, 2. This is minus 1, and then there will be 4, 4, which will be 1. Okay, so we have completed all of them, so we have 4 elements. For all elements, we have incorporated there according the local or the element stiffness matrix has been incorporated here, all of them, right? Okay, rest wherever we are not finding anything, we can just make it equal to 0. Yeah, so let me use here yellow color for that case. Okay, so what we get? We get 0 here. Yeah, and then we get 0 here. Then we get 0 here. Then we get 0. Yeah. So we have this stiffness matrix. Now we can just add them up and we can write, right? So what do we get here? 4 minus 3 minus 1. So we write k equal to a small k here. 4 minus 3 minus 1, 0. Okay. So 4 minus 3 minus 1, minus 3, 6. Minus 3, 6, minus 2, minus 1. Okay, so minus 3, 6, minus 2, minus 1. Okay, so minus 3, 6, minus 2, minus 1. Then minus 1, minus 2, 3, 0. Minus 1, minus 2, 3, 0. Okay, and then 0, minus 1, 0, 1. 0, minus 1, 0, 1. That's how we go. Yeah. Okay. Now, what you notice here is the diagonal term is always positive, and it should be positive. Remember that diagonal term should be positive. Yeah. Okay. That really means that the relation between force and displacement is positive. Basically, I mean, if you apply a force at a point in x direction, displacement has to be in x direction, or you apply a displacement in x direction, force you have to apply in x direction, not opposite. Yeah, so that really means that's why it is coming to positive number. You will also notice here you can actually cross check, especially for in case of a spring system, two noded elements, so what you can see here, I mean, not in fact in all a structural system, you will see if you have the structures, if you are working on a structures where forces displacements are related, then you can add all the rows or columns that will be equal to 0. So what you notice is 4 minus 3 minus 1, right, plus 0 will be equal to 0. You add all the terms, should be equal to 0, plus equal to 0, plus equal to 0. Yeah, this tells you only that summation of all the forces will be equal to 0, right? So you remember the one row, what it means? It really means that these are the forces when you have applied a unit displacement at node 1 while keeping all the nodes constraint, right? And then you measured all the forces. So when you measure all the forces, this has to be equal to 0, because on a structure, whatever forces is applied, if you add them together, that will be equal to 0. And that is why it will behave like that. Okay. Now, similarly, if you see this also, if you add them together, it was 0, and this is symmetric. This and this should match, and this and this should match. This and this should match, and this and this should match. Yeah. So these things you can check. Yeah, especially I'm talking about for the structural system when you have the force or displacements, right? They have to match. For other kinds of problem, it may or may not equal to 0 if you add them together. Okay, so any questions so far, guys?
No, sir.
Yeah, okay. Okay, now once you have that, the next thing is to solve the problem, and the problem is k. You can write it again: 4 minus 3 minus 1 0 minus 3 6 minus 2 minus 1 minus 1 minus 2 3 0 0 minus 1 0 1, right? And then u, and what is the u here? We can go back here. You see, this is the u. 0, u2, u3, 0. Right? So 0, u2, u3, 0 is equal to we have F1 50 0 F4, F1 50 F4. So F1 50 0 F4, right? So this is the equation you have to solve, and as we discussed earlier, since here this is 0 here, this is 0 here, and this will multiply to all of these, make it 0, and this will multiply all of these to make them 0. So finally, in this equation, these will not play any role. Yeah. So basically, you can make, so this one we will not consider, this one, right? This will not consider, right? And finally, your equation will be simply this multiplied by this equal to this, and then you have to invert to find out the u2 and u3. So you get 6 minus 2 minus 2 3, and u2 u3 equal to 50 0. That is the equation you have to solve. Yeah. So what do you get here? You get 6 minus 2 minus 2 is 6 minus 2 minus 2 3. So 6 minus 2 minus 2 3. Okay, of course there is a k here, so remember. And then u2 u3, this equal to, we have the 0 and 50, or 50 and 0. Okay, so we have 50 and 0. Okay, so this is the equation. Now we have to solve it, right? So we take inverse of that. So u2 u3 is equal to 1 over k, and then 6 minus 2 minus 2 3, inverse of that, and then 50 0, which is equal to 1 over k, and then we have 6. We are going to interchange this one, yeah, and then negative of that, yeah, is okay.
Yes, sir.
Okay, so 3 2 2 6, yeah, and then 50 0, and then we divide it by the determinant, and the determinant is 6 times 3 18, minus 4 is 14, right? So divided by 14, right? So we get 1 over 14k, and then you multiply that, so we get 150 here, and here we get 100, right? So this is what the answer is, right? So basically you have 100, 50 we can take it out, yeah. So this will be 50, 14k, and 3 and 2, right? So this will be 25 over 7k, and then 3 2. So this is u2 and u3. Now this value you can put back here in this system, yeah. If you value of u2 and u3, then you multiply, then you can use the complete of this you can use, then you can find out what the value of f1. So f1 will be equal to minus 3 multiplied by u2 minus 1 multiplied by u3 equal to f1, right? So you can use this complete matrix, you can find out the f1 and the f1 and f4, right? So simply you can find out f1. So we can also use like this, f1 and f4 is equal to, we can use that equation, remaining equation. So this equal to what? This multiplied by this, yeah. So basically what it tells you is finally 0 is multiplied to this one, and 0 multiplies to this one, so what remains is these two only, right? So multiplies by ut3. So this one and this one multiplied by this will give you f1 and f4, right? So minus 3 minus 1 minus 1 0, right? So minus 3 minus 1, so you can write like this, minus 3 minus 1 minus 1 0, and then you have u, of course k will be here, and then you have u2 and u3, right? So that's what that is. We have minus 3 minus 1 minus 1 0 multiplied by u2 u3, yeah, k will be here, and that will give you f1 and f4. Now f1 and f4, the value of u2 and u3 is 25 divided by 7k 3 2. So which is equal to k minus 3 minus 1 minus 1 0, yeah, and then 25 over 14k 3 2. That's what we have, right? Okay, that will be equal to, so you see k and k common here, okay, so cancels out, then 25 over 14, right? And then we have minus 3 minus 1 minus 1 0, and then 3 2 is equal to 25 over 14, and then we can write the answer, and the answer is this. This case
Minus.
-9 and -2, -11, right?
Yes, sir.
Okay. So -11 here, and the second one will be -3 simply. Right? Okay. Okay. So what you get here is this. So -25/14 and 11/3. That's it. So this is the answer. Okay. So typically you don't have the units, but if you have everything in SI units, you will know automatically that this will be Newton. Yeah. So in your exam, for example, you don't have to write units actually, yeah? Or unless it is asked. So, and in softwares also, the units, they don't give you units. So you would know the whatever, like what you expect the unit will be. Accordingly, you should assume it. Okay, so any question, guys? How problem is solved? And this is a basic concept that you will get again and again. Only thing, problem will keep on complicating, but this is the strategy you adopt. Yeah. So any question?
No, sir.
Yeah. Okay. Okay, so I see like attendance is low, so I just want to remind those who are not present. Okay, so 75% attendance requirement is going to be enforced. Okay, so that they should attend regularly. Okay, so we are actually recording all the attendance, and we will also share also. Okay, so I want to make it very clear. Okay, so I'm putting so much of efforts, and if the students are not coming, then I have to put this, I mean, strictly follow it, enforce it. Okay, now this regarding question number 2.2. So hold on. Okay. So problem number 2.2. So the first problem relates to the spring system. Now, problem 2.2 relates to the a continuous system. And what it says that the equivalent stiffness you have to find out. And for this, so this is a structure which looks like this, something like this. Okay, and what is given here is A is given, then this is 2B, again this is 2B which is given, and here it is L/10, and this is symmetric, so this L/10. Okay, yeah, and thickness is T. Now the question is, the problem is rather this to prove that K is equal to this equivalent K of the whole system. Equivalent K is equal to 5ETAB divided by A plus B L. So it says L dash, maybe L square or something probably. So we have to see. Yeah. So there's a typo actually. So this may be a square or something. So we can actually see that. So we have E. Then you have thickness. Then we have thickness here. So what we see is that it cancels out, two of them. No, it looks fine. So there will be L only, nothing else. Okay, now this where E is a Young's modulus given. So Young's modulus is given, yeah, and then you have to find out, use the finite element method to actually prove this one. Okay, so proving is one thing, but we can always look at from the finite element point of view, that how you look at this problem. Yeah, and looking at this one, what you know here is you can have number of element, one element, this one, then you have number 2 element from here to here, this is number 3 here to here, and then you have number 4 here to here. And what you see is number 1 and number 4 element both are identical, and similarly number 2 and number 3 are identical. So you can just find out what is the stiffness matrix for this element, same thing will be for this one. Similarly, if you find what is the stiffness matrix for this one, same thing you can use for the other one. Yeah. Okay, so that's what we will do. So we have two stiffness, two structures, and one is this, like this one, so which is this one. So we can use this one, this, and for this we have A from here to here, then we have L over 10, right? Okay, and then we have the thickness T. Yeah, so for this we have to find out what is the equivalent stiffness matrix, and then we have number 2, okay, and which is this. Yeah, and for this we have this thickness, and this thickness is 2b, right? And the length, this length we have, so this is the total length L, total length is L from here to here. So what we have now, L minus 2 times L over 10, because both of them are L over 10, so we have L over 5, so L minus L over 5, so L minus L over 5, which makes it 4 L over 5. So this is the length from here to here. Okay, so we have 2 elements, we can also number them. Always we start with the node number, so we can say this is node number 1, okay, and this is the node number 2, right? This is node number 3, this is node number 4, right? Okay, now element number we can put, this is element number 1, this element number 2, element number 3, element number 4. Yeah, and accordingly we can, now it says equivalent, we have to find out equivalent stiffness. Means what? Equivalent stiffness will be simply we give the unit displacement here, right? And we find out what is the force needed here to do it, right? This will be the equivalent stiffness, right? We fix at one end and you give a force of this. So actually this problem is something like we are going to fix this, right? And apply, we give U, what? U4 is equal to 1. And we have to find out F4 is equal to what? And this F4 will give us the equivalent stiffness, because U4 is 1. So whatever force we get here has to be equal to a stiffness, right? Force required per unit displacement, right? So F4 will be this is what we have to find out. Now what we have to do is take the first element, first and fourth both are same, and we know that this is A, right? Okay. So this is A, and then this is L over 10, right? Okay. So, and this is thickness is T. So what is cross-sectional area? A will be equal to, what is cross-sectional area? Anybody? If you look from this side, then this will look like this.
A into T.
A small a times T. Correct.
Yes.
Yeah. Because T is the thickness, and then A is like this. So A times T is the area. You know that A equal to E over L, right? And this case is E, capital A is AT divided by L is nothing but L over 10. And what you get is 10 EAT over L. Yeah. Okay. Now we have
Sir, your voice is
So
breaking.
your voice is
okay, sorry guys, there's some internet problem. Okay, so so what we have now is K, right? So K1 is equal to 10 EA over T, and this is element number 1, so the write K1. Also, what we have is element number 1 and 4. Both are similar, so we can also write K1 is equal to K4, right? K1 is equal to K4 actually. Now the next element, we have this, right? And we look at that. So we have 4L over 5 is the length, and then the 2B, this is 2B, right? Okay. So I want to make sure the length is same, the thickness. So this is 2B only. Okay. Okay. So yes. So this, sorry. So this one we have 4L over 5, and this one is 2B. Okay. Right. Okay. And rest E and all those things remains the same. And this is element number 2. So this is element number 2. So our K2, right, will be equal to, so L is specific to number 1. So we can also write E A1 over L1, and E remains the same for the all elements. So we'll keep E as the same one. So E A2 over L2 is equal to, now E, now A is 2B times T. So we write 2B times T is the area divided by L2 is 4L over 5. Yeah, so what do we get? We get 10 EBT divided by 4L, right? Or simply 5 over 2, or 5 EBT over 2L, which is equal to K3 as well, because 2 and 3 are the same actually, right? And because of that, K2 and K3 will be exactly the same. Same as like K1 and K4 are exactly the same. Hence, we can reuse it. Now, the element stiffness matrix, we know that Ke is equal to a small ke 1 minus 1 minus 1 1, right? So where K1, where E equal 1, 2, 3, and 4, right? There are 4 elements in this case. So this is valid like this, right? That we know. So now we can assemble the matrix, yeah. So we can assemble the matrix directly, the big K. So big K is equal to, right? We can assemble like this. And then we have 1, 2, 3, 4, 1, 2, 3, 4, right? Okay. Like that. Yeah. Okay. Now, when you assemble, then we have to look at the connection. First is from 1 to 2. So 1 to 2 is the first element, and the K is this, right? 10 EA T over L. So what we see here common, we can find out in both the things what is the common. And the common thing is we have E here also, we have T here also, T here also, then we have L here also. So we can have E times T, so I think we can also write, it's okay. I mean, we have 5 over 2 here. So even we could have 10 as common, so that we have divided by 4 here. So we can also do like this. Sorry, guys. Okay. So what will you do? So we have this E. Let's keep 10 E T over L as common. Okay. So we will have 10 E T over L as common, and then we can write everything. Okay. So first is 1, 2, 2, 1, and we have E AT over L. So in this case we have 10 ET over L already there. So we have just A part here. So we can write A from 1 to 2, right? So A minus A minus A. So first one is done, right? Okay, so from 1 to 2 we retain. Similarly from 3 to 4 also we can write the same thing, because that will be exactly the same, right? So from 3 to 4 we have 3, 4 here. So we have A minus A minus A. So the n blocks we have completed. Both of them we wrote already, right? So now this and this we have done. Now from 2 to 3 and 2 to 3, both of them are from 2 to 3 only. Means you can also actually you add the stiffness, because this and this are both added. Actually we will add it only, actually, right? So this, wherever whatever we get for this one, so finally this will be between node number 2 and 3. This is also node number 2 and 3. This also node number 2 and 3. So first, if you write for this one, then similarly this also will be at the same place, but we will be adding. So simply we can also have this multiplied by 2 and we can place it, right? Well,
In this case, our common becomes 10 E T over L. What remains here is B over 4, right? So we can write B over 4. We will add them twice, no problem. So we will use B over 4, but that is between 2 and 3, right? So this becomes B over 4 minus B over 4 minus B over 4 plus B over 4. And that is for which element? Element number 2. Now for element number 3, it is the same thing. Same and same place, just it will add again, right? Because this is exactly the same, right? So we will add here different element now. So plus B over 4 minus B over 4 minus B over 4 plus B over 4, right? So we get the stiffness matrix now. Okay, all others places will be 0, so we don't get here. So 0, 0, 0, 0 here, 0 here, 0 here. So we get this stiffness matrix. Okay, so final value you can write what we have is A. We have A minus A 0, 0 minus A plus B over 2, and then we have minus B over 2, right? And so on. So let's write. So K will be equal to 10 E T over L, and then we have value A minus A 0, 0, A minus A 0, 0. Okay, now next is minus A plus B over 2, minus A plus B over 2, minus B over 2, 0. Okay, then we have 0 minus B over 2, then A plus B over 2, then minus A. So we can also
Sir, it's symmetric.
symmetric, so you can also write, so you don't have to look at that. You can also write symmetric. So it becomes minus A 0. Okay, and then here it will be minus B over 2 0, and then at this place, what should be the thing at here?
Sir, A plus
We'll
B
have
by
to
2.
see.
Yeah, so this will be, you have to see that. So this will be A plus B over 2, that is there. So if you see here, A plus B over 2, then minus A, right? This is minus A, sorry. You can also find out from here, so since you know this and this, all of them should be 0, so you will know automatically what should the value will be. So A is matching, right? And here this and this matching, so this has to be, so something is wrong.
Sir, in 3, 1,
Yeah. So I think the first one, this will be 0, right? This one. I think this is 0. This is 0. Yeah, this has to be 0, right? So this is 0 because this is 0, so I made a mistake here. So A minus 1, 0 here, so say 0, 0, 0 here. So minus B over 2 here, so this and this cancels out. Now A, we get minus A here. So minus A, here we have minus A, and then we will definitely get A here. Why? Because it has to be 0. So this also, this way also you can check, or you can check from, we can just 0, 0 minus AA, 0, 0 minus AA, and then you have 0 minus B over 2, A plus B over 2 minus A. So similarly, we have 0 minus B over 2, A plus B over 2 minus. So this is what the K is, right? So once you get that, then what problem you have to solve? You have to find out the force. So you know that K U equal to F, where U is equal to nothing but the first is fixed. So u1 equal to 0, then you don't know what the u2 is, you don't know what u3 is, and u4 is equal to 1. Remember, right? You have given, what is the problem? You have to find out the equivalent stiffness. And how you are finding? You are doing an experiment in which the so you are doing experiment in which the left ends of this structure you are fixing, and a right one you are giving a unit displacement, and you want to find out what is the force that you need to give unit displacement. That would be the stiffness, that would be the equivalent stiffness. That's what you are doing. That means u1 equal to 0 because you are fixing it, u2 you don't know because this one you don't know, u3 you don't know, u4 you know, u4 equal to 1, and you want to find out u4. So you don't need to invert the matrix here. Okay, that's the message. What do you do? Here u4 equal to 1, and finally the you have to, okay, no, you have to invert a matrix, otherwise you will not know u3 and u4, u2 and u3. Since you don't know u2 and u3, you cannot get f4. So you need to actually, where f is equal to, you have force you don't know, first one, which force? F1 you don't know because this is fixed. F2 is equal to 0 because there is no force applied. F3 equal to 0 because no force applied. And then you have F4, right? And F4 you have to find out, right? Yeah. Okay. So finally, the problem when you write, then you will know what you want to do. So 10 ET over L, and then okay, then we have a minus a minus a 0 0. Okay, maybe we give less space. A minus a 0 0 minus a plus b minus b, so minus a plus b over 2 minus b over 2 0 0 minus b over 2 0 minus b over 2 a plus b over 2 minus a, and 0 0 minus a. So 0 0 minus a. Multiplied by, you have 0, then you have u2 you don't know, u3 you don't know, then u4 which is equal to 1, right? And equal to you have the f1 you don't know. So f1 you don't know, f2 is 0, f3 is 0, f4 you have to find out, so you don't know. So this is the equation, right? And you now repeat the same thing. What happens? What do you have to find out? You have to find out f4. But in order to find out f4, what do you need to know? f4 will be simply this multiplied by 0, this multiplied by 0, u3 multiplied by minus a and plus a, right? So this not needed, but you need to know u3 in order to find out f4. And how do you find out? You will find out by inverting it. But there is a problem here. Earlier it used to be 0 here. If it multiplies by this, becomes 0 0 0 0. So it's okay. This we can neglect, right? And then neglect means not neglect, but we don't consider because we invert. But now you have 1. This will make all 0, but this will not, right? This will multiplied by minus a, it will be like this and like that, right? So how will you do it? So in that case, like last, if you see this, if you multiply this to this one, then The last one, whatever you multiply, so what I mean to say is like this. So yeah, same system, you can write it like this: 10 ET over L, right? And then we do like this: A minus A0 minus A plus B over 2 minus B over 2, then 0 minus B over 2, A plus B over 2, 0, 0 minus A, right? Okay, and then you have 3 now, and by 3, this one, we multiply like this, right? So will be 0, U2, U3, yeah, plus, now what you are doing? The first equation, if you see, first equation is this multiplied by this. So this multiplied by this by this plus this multiplied by this. Now this one I'm taking away basically. Yeah. So this will be 10 ET over L.
Sir,
Yeah.
sir, as there are two variables and we have two equations,
Hmm.
so can't we solve it like that?
Two variables, two equations. No, we have four variables, four equations.
No, sir. We have to first find U2 and U3,
Hmm.
and our final answer will be F4 only. What we need in the last calculation.
Hmm.
So, like we can multiply the matrices and find U2 and U3 by equating them to 0.
Yeah, I mean, you mean to say this and this multiplied by this, right?
Yes, sir.
Yeah, but so this you can do by hand, but when you are writing computer program, you cannot do it right like that. You follow?
Okay.
Yeah, so we have to understand how the computer will do. Yeah, so this example tells you how should you program, So in order to program, what you will do is simply the last row corresponding to this one, you just multiply this to this and subtract from this. You got it. And then you can go ahead with that. Got it?
Uh, uh,
So
okay. Let's
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 write here.
proceed and
Yeah,
let's.
sure. So this one I'm keeping it here. Then you have this guy here multiplied by 1, right? This one will be multiplied here, right? Multiplied by 1 here, because why? See, this multiplied by this is nothing but this multiplied by this plus this multiplied by that, right? Simply, if you see, I have just segregated this one, right? This one we have, this is nothing but till here, and this one is here. So 3 I have put here, remaining 1 I have put here. So it is the same equation but writing separately, so that this is known now, right? Because I'm multiplying by 1, this is known. If this were 0, this would be 0 here and this will not matter. But since this is non-zero, it will be a value here, and which is equal to we have F1 0 0 F4, right? Yeah. So next what we will consider, now you see this goes here, and in all cases this is going, so this is not going to matter, so we can cancel now. We can remove this one. Yeah. Okay. So just a minute. So next step, let me write the next step, then you will understand. So next step is 10 ET over L, and then we have A minus A 0 0, only 0. Then we have minus A plus B over 2, then minus b over 2, minus b over 2, then we have 0 minus b over 2, 0 minus b over 2, a
plus
plus
b by 2.
b over 2, then we have 0, 0 minus a, 0, 0 minus a, right? So we have this, and then multiplied by 0 u2 u3, so 0 u2 u3, right, is equal to, now we will write here what we had. We have f1 0 0 f4 minus 10 et over L, right, and then we have the last column, which was this 0 0 minus a, so 0 0 minus a multiplied by 1 coming from, since 1 was here, u4 equal to 1, so this is 1, it will come here 1, which is equal to what? So this is 0 0, so nothing will not matter, right? But it will matter for others. So what we get here, f1, because 0, so it will not matter, 0 is here also 0, so this will be 0. Third, you see 0 here, and here minus, here minus plus. So what we get is 10
EAT by L.
Yes. So we get 10 EAT over L, right? And in this case, it will be just the negative of that, right? So we get a minus 10 EAT over L.
F4 also.
And F4, sorry, yes, you are right. So we will have F4 here. F4 minus, yes. Yeah. So in a way, what you are getting is actually force. Although there are no force, actually it induces some kind of force. Basically, that really means. So now you want to solve this system now, right? So now this is equal to this. It is right. Now first equation has F4. Last equation has F4, right? F1 here is F4. So only you want to solve only these two equations now, right? These two rows. This equal to this one, this equal to, sorry, this multiplied by this multiplied by this multiplied by this, and so on, right? So finally, what happens is, if you consider just the equation which doesn't have F1 and F4, then that will be which one? Which equation? Will be the second and third. This and this will be equal to this and this. So, but here this multiplies to 0, right? So 0 here and 0 here. So what remains is this. So this multiplied by u2, u3 will be equal to this. You follow? Okay, so what you get from here is a plus minus b2. Okay, so you get from there E A E T over L, sorry, E T over L, 10 E, right? 10 ET, 10 ET over L, and then you have this A plus B2. So A plus B2 minus B2 minus B2, A plus B2. That's what you get, right? So this multiplied by U2, U3, U2, U3 is equal to
0 and
0, 10 EAT over L, right? So you get 0, 10 EAT over L. And then this you can solve, you can find out the value of U2 and U3. Then this value U2 and U3, you go and put in the original equation, this equation, right? And then you can find out F and F4. This is a lengthy, So, but that finite element analysis is supposed to be done by computers. Yeah, so that's why. But here the main thing is understanding the equation actually, and don't try to solve using equations. Then it will not serve the purpose. If you are writing the equations, 4 equations, try to solve it, then your method is not cannot be applied to a big problem then, right?
So basically, we are like, you are explaining us the logic which we'll have to explain to the computer program, so that it performs.
Yes, yeah, yes. So accordingly, you have to like write the program such a way that the same kind of operation can be done regardless of how many equations or how many degree of freedom you have. You should be able to do this basic thing. Yeah. So it will look for the 0. If 0 is there, you can remove those rows and column. But if it is non-zero, then you have to do this kind of thing. Meaning that you multiply the displacement to the stiffness and bring it to the force side, and then you find out the like this. Yeah. Any question? Okay. Okay, guys, the rest, please, you complete it. Okay, so the idea was to show, actually tell how to deal with it while programming. So the program logic, you should know how to implement it. And we will come back to it. We will have this kind of problem when we are using computers. Using computers means I will send you some files which will solve some problem. Okay. So any questions? Any other questions?
No, sir.
No, sir.
Okay. If no other questions, okay, thank you very much. We'll see you tomorrow at 10 o'clock. Okay.
Thank you, sir.
Thank you. Good night, everybody.
Thank you, sir.